Good day, ladies and gentlemen. I welcome you again to Simplified RSA. We are the guys who makes it look easy. Today, I want us to talk about annuities under financial mathematics. Financial mathematics is one of the nicest chapters in the mathematics curriculum, such that I thought that unlike working with the algebras of X and Y's, with financial maths, because it is given that everyone loves money, it was one of those chapters whereby we were supposed to excel on it. But then, whenever we are applying the mathematics in those paragraphs that are given in the question, everything just becomes a problem. The way I've observed with the way students are approaching the questions or the problems rather. So today, let's talk about annuities, right? First of all, I want you to understand that whenever we talk about annuities, we are talking about equal payments that are done into or out of an account of some sort. So now, so far we know that we have present value of annuity and we have future value of annuity. And you are given the formula sheet for your exams, both the formulas of present value of annuity and future value of annuity is given. Now, like I said, annuity is equal payments being paid in or out of the account. Now, the question would be, how do I figure out whether I'm facing with a question that has something to do with present value of annuity or future value of annuity? Let's start with present value. Think of it like this. So we are talking about payments of equal values, right? Suppose I'm doing the payments. Think of this as the account that I'm paying into. So I'm making the payments every month, equal payment, every month, equal payment like that, every month, equal payment like that. Now I am paying into the account. The payments are made into the account such that at the end of the period of the question, I expect to have a certain amount on that account. So I expect to have something in the account because I've been paying into that account. So in this regard, we are talking about future value of annuity because in the future, there will be a balance in the account. Now, the opposite of that, which is present value of annuity, is if I've taken a loan of some sort, for example, after I've taken a loan of some sort, at some period, I have to make payments of that loan from my account to pay the loan out. So now, if I'm making payments from the account out to pay something, now I'm paying something, removing from the account, paying something, removing from the account, making payments, removing from the account, making payments, removing from the account, making payments, such that this process, if I was to imagine a fixed account of some sort, at the end of the account, there wouldn't be anything in the account. In that case, we are talking about present value of annuity. So that's the difference. If money is being paid into the account, such that at the end of the day, you expect to have a balance, that's future value of annuity. If money is paid out from the account, such that at the end of the period, you expect not to have anything on the account, that would be present value of annuity. So in other ways, present value of annuity is when we are paying off a debt or a loan of some sort, or whatever the situation may be, but money is going out of the account such that at the end of the period, if the account was fixed with a certain amount, we would imagine that there wouldn't be anything in the account. And future value of annuity is when you are saving into the account, such that in future, at the end of the period, you expect to have a certain balance on the account. I believe that's the example for us to understand the difference between present value and future value of annuity. Now, let's talk about our formulas for present value of annuity and future value of annuity that are given in the formula sheet, right? So this is what you have. We have future value of annuity whereby it is denoted by F. And then F is equals to X into 1 plus I, and then we have N there, and then we have I there. So also with present value, P for present value, and then we have X, we have I, we have N there. What you need to know is that X denotes the payments that are made. Equal payments, they must be equal. So X denotes the payments, F being the future value, P being the present value. So whatever we have, the variables we have on the left-hand side, they are common. But for both formulas, X stands for the payment. So this X or this X stands, or it represents the payments. And then we have I. I represents the interest rate. I denote the interest rates. And we have N. N stands for the term. You can call it the term or the period or the time it takes for the payments to be made on those equal payments, which are done either monthly, weekly, daily, regardless of the situation. So now, X is the equal payments, I is the interest rate, N is the term or the period. The interesting thing about such question is that on a paragraph of a given question, you'll always have compounding period. So they'll always tell you that it is compounded monthly, it is compounded weekly, it is compounded yearly, whatever situation we may have there. So the compounding period, you must always divide your compounding period on I. So you must always say I divided by the compounding period, and you must also multiply the compounding period on N, such that in advance, if we advance this, our I has to be that I divided by the compounding period. And also our N has to be that N times compounding period. I'm going to use M to denote compounding period. So the compounding period M is equals to 12 if it is compounded monthly. M is equals to 365 if it is compounded daily. Sometimes they may say it is compounded semi-annually, where M is equals to 2, semi-annually meaning 2 times a year. And we may have quarterly. If it is compounded quarterly, we may have M being equals to 4 throughout. Now, if you look at this, the formula now, it should be such that the compounding period is divided on the interest and the compounding period is multiplied on the term. So picture our formula now in a complete form. If we can picture our formula in complete form, we should expect something of this sort. F is equals to X into 1 plus. Instead of writing I will then write the I divided by the compounding period, like that. To the exponent of N times the compounding period, like that. Minus 1 minus 1 all over I divided by the compounding period, like that. So for me to use this formula, it is very much advisable that I picture the formula to be like this, because the compounding period will always be there. And for me to use either this formula or this formula, the period N, I must make sure that before I substitute N into any of these formulas, N must always be in years. Not always will they give you N in the form of years. Sometimes they'll tell you the payments were made for 6 months. If the payments were made for 6 months, I know that I can convert 6 months into a year. How do I do that? To convert 6 months into a year, for example, I will say N is equals to 6 divided by, I have 12 months in a year. This will give me 0.5, which means this is half a year, or 1 over 2, which means this is half a year. Sometimes they may say the payments are done for a couple of months or a couple of days or a couple of weeks. But before I can substitute the value of N on the formula, I must make sure I convert the N into years all the time. So now the best way to picture this formula, whether it's for present value of annuity and whether it's the future value of annuity or present value of annuity, I must always know that the I will always divide it by the compounding period, as you can see here. And the N, I will always multiply it by the compounding period. So in order for me to use this formula, I must always picture it like this. As you can see, M stands for the compounding period. And another thing that I have to make sure of is to make sure that for N, I must always make sure that N is substituted in years whenever I use any of these formulas. That's what we should know about the formulas. Now, let's try to put this into practice. The question that we are doing is the selected question that I'm going to put somewhere on the screen. We will start with 6.2. I believe on this video, we're just going to do 6.2, and then I'm going to cut the video into two parts. 6.3 will be done on a separate video just to make sure the videos are not that long for all the students to be able to understand. So for 6.2, the question goes like, on the 31st of January 2022, Tino deposited 1,000 in an account that paid interest at 7.5 per annum, compounded monthly. So we have the compounding period there, M, compounded monthly. He then, after making the first deposit, he then continued depositing 1,000 on the last day of every month, meaning now it's equal payments on the last day of every month. And the first deposit was done on the 31st of January, which is the last day of January. So the last day of every month, Tino is making deposits of 1,000 rands like that, meaning it's equal deposits into an account. So when Tino is making deposit into the accounts, Tino expects to have a certain balance at the end of the period inside that account where Tino is making the payments into. So now this should ring a bell that we are talking about future value of annuity. And then the question goes on and say, will Tino have, okay, no. He will make the last deposits on the 31st of December 2022. So from January, at the end of every month, he made deposits, and the last deposit would be made on the 31st of December 2022. Now, the question is, will Tino have sufficient funds in the account on the 1st of January 2023 to buy a computer that costs 13,000? Justify your answer by means of an appropriate calculations if Tino will afford that computer, which is 13,000. So far we know that Tino is making payments into the account, which is saving, right? And we know that at the end of the period, Tino expects to have a balance on that account. So we already know we are dealing with future value of annuity. But the question is, those payments that he's making, will they be enough for him to get or to afford a computer that is 13,000? So that means then we have to determine if the future value is it going to be 13,000 or not. That's how we know that Tino will be able to afford the computer or not. Now let's break down the question. So since I picked up that the situation I have here is future value of annuity, I have to calculate the future value of the deposits that Tino is making. This is the formula that I'm given in the formula sheet. But in my head, I know that the interest I will have to divide it by the compounding period, and also this one here. And N, I have to multiply it by the compounding period. Therefore, here, I just denoted the formula to show that actually, or the interest should be divided by the compounding period, and the period must be multiplied by the compounding period. Now, let's have a data set to show what information do I have based on the variables that are on the formula. So the information that I have is that X, which is the payments that are done monthly, Tino is depositing 1,000 rand. Also, I know that interest rate is 7.5%. If interest rate is 7.5, my interest rate, I must always divide it by 100% in order to substitute on the formula. So also another thing I forgot to mention, whenever you are dealing with I, you must always divide it by 100%. So this is going to be 0.075. So my interest rate is 0.075. What else do I have? I have the compounding period M, which I'm going to divide there. The compounding period, I was told that it is compounded monthly, which means M will be 12 because I have 12 months in a year. So I have all the variables except for the term. So to get the term, I need to determine N. To determine N, which is the period of the payment, the best way to think about it is to count from the 31st of January 2022 up to the last payment, which is 31st of December 2022. How many years are involved there? To determine the term, the best way to determine the term is to put all the payments into some sort of a timeline. We call this a timeline. It's like a number line. So I know that the first payment was made on the 31st of January. On the 31st of January, there was the first payment. The second payment was made at the end of every month, right? The second payment, it was made on the 29th of February, or rather, regardless of whatever day it was, whether it was a leap year or not, it was made on the month end of that second month. So third month, fourth month, fifth month, sixth month, seventh month, 8 month, 9 months, 10 month, 11 month, 12 months. So I know that for 12 months, there were payments coming in at the end of each and every month. So I want to know how many months, how many years was that? Obviously, I can tell it's a year, but in terms of months, I can just convert it like this. I'm going to count the number of payments that were made. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which ends on the 31st of December. So it's 12 payments from January to December. So the number of years is going to be 12 months, but because it is in months, I will divide by 12 again because I know that I have 12 months in a year, which is going to give me 1, which practically states that the payments were done for a period of a year. But even without this calculation, anyone can see that let me get a proper marker there. So this is going to be 1 year, meaning N is 1. N is 1, like that. So I have all the information I have to substitute on the formula to get the future value. Now, let's substitute. Now, F is equals to 1,000 Rand for payment X into 1 plus 0.075 divided by the interest, divided by the compounding period. It's compounded monthly 12 to the exponent 1 because it was done for 1 year. 1 times the compounding period, which is 12. So 1 times 12 minus 1 all over the compounding period, interest dividing by the compounding period all over 0.075 divided by 12. So what I've done here is, from this formula, I substituted every information I have based on the data that I created from the variables that I need to calculate. And from here, guys, I know that now you guys use fancy calculator such that you can simplify this with a calculator to get the actual future value of the payments of 1,000 with the condition that are given on the question. And if I punch this on the calculator, the answer will be 12,421 Rand 22 cents. That's what I will have. Now remember, the question was, will Tino have sufficient funds in the account on the 1st of January to buy a computer that is worth 13,000? and we had to justify our answers by calculations. So after getting a future value of 12,421.22 cents, the answer is that no, Tino will not have sufficient funds in the account. In fact, he is missing a couple of friends there to reach 13,000, which, to be accurate, he needs 578.78 more for him to reach 13,000. So the answer is no. By January 2023, Tino wouldn't have enough money to can afford the computer. So the key here was to pick up as to between present value of annuity and future value of annuity, which formula are you going to use? And after examining that the payments are done or the payments are made into the account such that Tino was expected to find a balance at the end of the period, that's how we picked up that this was future value of annuity. And to determine how much will be in the savings after a certain time was the way the question was asked, because we had to find out if Tino will afford the computer, which cost 13,000. So clearly we can tell that Tino is making savings towards the computer. But unfortunately, after 12 months, the money was not enough to can reach 13,000. It was just a bit less there by a couple of rands, 500 rands J above that. So at the end of the day, that's how you approach such question. Join us on the next video as we proceed with 6.3. We're gonna do 6.3 on the next video. Make sure you follow us, you subscribe, you hit the reminder button just to make sure you are reminded whenever the second video is uploaded. Thank you for watching up to this far. I'm Mr. Maimane. This is Simplified RSA. We are the guys who makes it looks easy. And feel free to inquire about our private lessons. We offer private lessons at a very affordable fee. Send us a WhatsApp or an email, or yeah, you can just call us directly. Until next video, join us then.